welcome to video number 35. We're going to be talking about simple harmonic motion again, and we're going to be talking about what you need to know, kind of like givens in simple harmonic motion. So of course we have the period, which is represented by T, big T. Then we have frequency, and then we also have angular frequency, which is in radians per second. This one's in hertz, and this one's in seconds. All right. So let's see a diagram for a common oscillating system. Let's go with the spring system on its side. So here we have a spring system, oscillating spring system, frictionless surface, and this is the reference point. This is its maximum position. Minimum position, we're going to call it A and negative A. Alright, so this distance here and this distance here, they're both equal. And then, so as object C is stretched out to position A and let go, it will oscillate over to position negative A and then back to A. So at both A and negative A, the velocity is equal to 0. And then at x equals 0, C reaches its maximum velocity. It reaches its maximum velocity. So, when we have this system, we also have a couple of equations that we can use to figure out the velocity if we wanted to. For example, if we want to find the velocity at some point, we have the equation velocity is equal to negative A times angular frequency times the sine of angular frequency times T. Okay, now let's take a look at problem number 35. So once again, we have a spring system. This is initial or reference point x equals 0. Then we have, this is 15 centimeters, and it is dragged down to here, and then let go. So problem number 35 equals, which of the following statements is true of the magnitude of the acceleration of the object at time equals t, at time t is 1 second. All right, so at 1 second. We know that the period, a given is that the period is 2 seconds. So at 1 second, it would be up here at its max, 15 centimeters above the reference point. So somewhere around here. All right, so what would be its acceleration? So acceleration is the change in velocity. We know that the velocity at this point is 0. But since it's changing so right before it, it's changing from positive, it's going up, or I get direction is going from up down to down. It's changing velocities, meaning the acceleration is actually at its maximum value, while the velocity in the middle, which is at its max, means that the acceleration, since there's no change or very little change, is actually 0 in the very middle. So when it's at its top, it reaches its maximum value. And question number 35, that would be answer D.